Hi guys, welcome back to my channel. How are you guys? I'm hoping for your good health. So see that look at that question. We will discuss this question first before I proceed further for the chemical and physical properties of covalent compound. Now, I have taken this question from the OCR textbook and I've seen one of the past paper that question appeared like draw a dot and cross structure of ethene molecule. That's why I have taken this question. Okay, do you want to try it? Fluorine molecule, easy though. Fluorine has how many electrons in the outer shell? 7. Fluorine is from group 7 element. Dot 1, 2, 3, 4, 5, 6, 7, and one more fluorine, which has 7 electrons. 1, 2, 3, 4, 5, 6, 7. After sharing, they have 8 electrons in the common shell. Okay, and we know that a covalent bond is formed between two nonmetals. If suppose they will ask you what type of chemical bond is present in any of the following compound, they will give you draw a dot and cross structure of ethene and mention the type of bonding present in ethene. So ethene is a compound having carbon and hydrogen. So what type of chemical bond is present? Obviously covalent. Okay, now hydrogen fluoride, fluorine molecule, hydrogen fluoride, HF. Hydrogen has how many electrons in the outermost shell? 1. And just now we have done fluorine. Fluorine has 7. 1, 2, 3, 4, 5, 6, and 1, 7. HF. Easy. Dot and cross structure is very easy, guys. And these remaining pair of electrons are called lone pair. Now, SiF4. I have shown in my videos methane molecule. So SiF4 is similar to methane molecule. Silicon tetrafluoride. Can I rub the board here? If you don't mind, can I rub the board, guys? Okay. Silicon is from group 4. So having how many electron in the outermost shell? Has 4 electron in the outermost shell. Look at that. Silicon has 4 electron in the outermost shell. Si from group 4 has 4 electron in the outermost shell. 1, 2, 3, 4, and all are shared with 4 fluorine. 1, 2, 3, and 4 fluorine. Fluorine has how many? 1 and 7 remaining. 1, 2, 3, 4, 5, 6, 7. 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. This is the dot and cross structure of SiF4. Now, sulfur dichloride, SCl2. Sulfur dichloride. Check. Sulfur is from group 6. What does it mean? It has 6 electrons in its valence shell. So draw 6 electrons for sulfur. Sulfur is the central atom for SCl2. Silicon is the central atom for SF4. Central atom is the main atom around which some non-metals are grouped to form covalent compounds. Why I'm stressing central atom? When I will teach you how to draw the shape of the molecule or how to predict the bond angle of the molecule, that will be very important. We have to discuss in terms of central atom. So the bond angle we will discuss in terms of central atom. Okay. Now CCl2. Sulfur has how many in the outermost shell? 6. 1, 2, 3, 4, 5, 6. And chlorine need only 1 to get 8 electron. So 1 chlorine has 7. 1, 2, sorry, dot cross. 3, 4, 5, 6, 7. So this chlorine 1, 2, 3, 4, 5, 6, 7, 8. Outermost shell is completely filled. One more chlorine. 1, 2, 3, 4, 5, 6, 7. This chlorine has 8 electron after sharing. Sulfur has 8 electron after sharing. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, carbon disulfide, like carbon dioxide. This structure is very similar to carbon dioxide. So I'm doing for that, you will try for carbon dioxide. Okay, look at that. Carbon is the central atom for carbon disulfide, like oxide, this is sulfide. Any non-metal we named as ide when they form compound. There's a difference between ite and ate. I will teach you ite and ate. Or you can watch my videos on titration. I have already explained the difference between ITE and ATE or IDE. Now, carbon has how many in the outermost shell? 4. 1, 2, 3, 4. Sulfur need how many, guys? How many electron to get 8 electron in the outermost shell, or to get full outermost electronic configuration? Sulfur need 2. So look at that. Sulfur and carbon always make a double bond because sulfur need 2 electron. Sulfur has how many? 6. 1, 2, 3, 4, 5, and 6. Double bond. 6 group and 4 group, always there will be one double bond. And this also, again, sulfur need 2 electron. 2 electrons shared by carbon and 2 electrons shared by sulfur. So there will be one more double bond. Here is a double bond. Sulfur 1, 2, 3, 4, 5, 6. Look at the structure. This is like this. No, it's not a bend, it's linear. I will teach you the shape of the molecule, don't worry. Carbon, double bond S, double bond S. Single bond is called sigma bond, and a double bond is called pi bond. So sigma, sigma, pi, pi. Sorry, guys. Ethene. I've seen this question in the past paper. Ethene, carbon and hydrogen. Ethene is an example of hydrocarbon. Hydrocarbon contain carbon and hydrogen molecule, and they bonded each other by means of a covalent bond. Okay, hydrocarbon, no worries, I will teach you later on. Hydrocarbon, ethene molecule, C2H4, ethene, C2H4, ethene. Ethene is a gas. Ethene molecule. Ethene. Carbon. Look at carbon. And we know the carbon has how many electrons in the outermost shell? 1, 2, 3, 4. And 2 carbon. Sorry, I want to draw the 2 carbon. I need a bigger space. 2 carbon. Look at the 2 carbon. This is a carbon. First we will do bonding between carbon and carbon. Then I will show the sharing between carbon and hydrogen. This carbon has 2 electrons in the outermost shell. This carbon also has 2 electrons in the outermost shell. 1 and a 2. 1 dot 1 cross this carbon. Now, each carbon has 2 more electrons left. This carbon has 1 electron left, 1 electron left. This carbon has dot and a dot, 2 electrons left. So this carbon share with 1 electron with 1 hydrogen. Hydrogen can only share 1 electron with this hydrogen. But this carbon also share 1 electron with hydrogen and 1 more electron with this hydrogen. Look at this molecule. Quite interesting molecule. I will draw how it looks. Carbon, carbon and a carbon, double bond, 2 hydrogen, single bond and a single bond. This is also a single bond. This is a single bond. Sigma, 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 pi. Okay. Carbon dioxide and sulfur dioxide, same. I'm not doing carbon dioxide. You will try it. Now, hydrogen cyanide, HCN. Now, okay, can I rub the board, guys? HCN, hydrogen cyanide. Hydrogen is a non-metal, carbon is a non-metal, and nitrogen is a non-metal. They all three combine to form HCN, hydrogen cyanide. Okay. Let's focus on carbon. Carbon has how many electrons in the outermost shell? 4. This carbon share 1 electron with hydrogen because hydrogen can share only 1. How many electrons left with this carbon, guys? 3 electrons. Look at that. 3 electrons. 1 dot, 1 cross, 1 more cross, 1 more cross. Okay. Nitrogen is from group 5. Group 5 meaning nitrogen has 5 valence electrons. To get full outer shell electronic configuration, it shares with 3 more electrons. So this nitrogen shares 3 electrons from carbon. So big nitrogen molecule here, and it shares how many electrons? 1, 2, 3. And nitrogen has 1 lone pair. This is the lone pair of the electron. So hydrogen, a single bond with carbon, a triple bond with nitrogen. This is the structure. I will teach you the bond angle and the shape. Don't worry about the bond angle and the shape. Okay, we have done this question nicely. Now, physical properties and some chemical properties of the covalent compounds. Okay. Properties of the covalent bonded compounds or covalent compounds. Properties of covalent compounds. Since covalent bond is formed by sharing a pair of electrons, it is not a strong bond. It is a weak bond compared to ionic bond. The force of attraction is very weak. What type of force of attraction? A wonderful type of force of attraction. Based on the force of attraction, I will make a separate video. Don't worry about it. Well, it's a weak force of attraction between the atoms of non-metal. Compared to ionic bond, there's a weak force of attraction. So we would expect less melting point and a boiling point. And one more thing, guys, keep in your mind that here, here I'm discussing simple covalent compounds. I will teach you giant or macro covalent compound later on, which is slightly different from simple covalent compound. Okay. So I keep on telling. So keep in your mind that here we are doing only simple covalent compounds, not the macro covalent compound or not the macromolecules. Now, properties of simple covalent compounds. Properties of simple molecules or simple covalent compounds. Covalent compounds. Like just now explained, it is formed by sharing a pair of electrons, so they have less melting point and a boiling point. Important property, they have less melting point and a boiling point. Less melting point, less melting point and a boiling point. And can I write simply BP? That's boiling point. Yep. Now, solubility. In general, I'm not talking about the polar and non-polar. In general, they are not soluble in water molecule. They are insoluble in water molecule. We will discuss polar and non-polar later on. So they are so the polar covalent compound soluble in water. I do agree. I'm coming to the point of polar and non-polar covalent compounds later on. They are they are insoluble. That's the journal trend. That's the journal property. They are insoluble in polar solvent, or you can say water molecule. They are insoluble in water molecule. They're insoluble in water, and they do not conduct electricity. They do not conduct electricity because there is no movement of electron. In case of ionic compound, there will be a movement of ions. Free ions we have seen in case of aqueous solution and molten solution. Here there is no free electrons. So they are bad conductor of electricity. Except one compound. I told you I will teach macromolecule. Can you give me the example of one of the macromolecule which conduct electricity? Any idea? It is a form of carbon. Graphite. Graphite is a macromolecule which conduct electricity, and because of a delocalized electron. So when they will ask you why the ionic compound conduct electricity, your answer will be due to the movement of free ions. Don't use the term delocalized electron. Most of my students, delocalized electron you have to use in terms of graphite or metallic compounds. Metallic compounds, they conduct the electricity because of the presence of delocalized electron, and graphite also because of the presence of delocalized electron. Okay, but in general they will not conduct electricity. They are the bad conductors of electricity except graphite. Okay guys, these are the some physical properties of covalent compounds. Yeah, that's the general properties. We will discuss later on. Because of the presence of hydrogen bonding, they are dissolved in water. That's a different case. But in general, they have less melting and boiling point. They are insoluble in polar solvent. Example like water. They are bad conductors of electricity. Now, okay. Now, covalent compounds. They are of two types: polar covalent compounds, polar covalent compounds, and non-polar covalent compounds. Non-polar covalent compounds. Okay, best example, water molecule. This is benzene molecule. Okay, guys, thanks for watching this video. I want to stop this video and I will continue the difference between the polar and non-polar covalent compound. Why this compound, suppose like I said to you, water is a polar molecule. Why water is a polar molecule? And I gave you the example of benzene, why benzene is non-polar. We will discuss this one. Okay guys, thanks for watching this video.